All right, in 5.3 part 2, we are going to take a look at the unit circle. So what this is connecting lots of exact trig values with points on a circle. Okay? The unit circle is just defined as a circle centered at the origin with a radius of exactly 1. Okay? So right off the bat, we know a few specific points on that circle. Right? If we have a radius of 1, all the point 1, 0, the point 0, 1, the point negative 1, 0, and the point 0, negative 1 will all be on that circle. So what we want to start to do is start connecting angle measures with points on the circle. So if we think about the angle measures for those points, right? Again, thinking in standard position. So I'm starting on the positive x-axis, right? I'm starting here, right? So first, we could actually say that we're starting here at a degree measure of 0 degrees, or we could say 0 radians. Then if I want to take my angle up to here, okay, that would be a 90-degree angle, right? We could say that that's either 90 degrees, or we could say that that's pi over 2 in terms of radians. If we go all the way to the point, or to the next um, line over here, right, the negative x-axis, that would be a 180-degree measure, or an angle of pi. If we go all the way down to here, that would be 270 degrees, or an angle of 3 pi over 2. And we could say if we go all the way back around, that would be 360 degrees, or 2 pi. Right now, I should mention that I just gave you some space at the top to write down whatever you feel like you need to write down as we're constructing the unit circle. Okay, then at the bottom there, we will just fill in the entire unit circle. So whatever notes you want to take up there at the top as we're constructing the unit circle, so you understand what we're doing, that's totally up to you. Okay, so these are the angle measures for those points that we just mentioned. Right, starting at 0, then 90, 180, 270, 360, and then we also listed those in terms of radians. Okay, now we do want to get in the habit of being able to go back and forth between radians and degrees fairly seamlessly. Okay, so I know right now we're probably more comfortable thinking in terms of degrees, and that's okay. Okay, but as we start going through these a lot more, right, we want to get as comfortable thinking in terms of radians as we do in degrees. Okay, so now we're going to put a few more specific points on the unit circle. And we're going to use our special right triangles, our 30, 60, 90, and our 45, 45, 90 to do that. Okay, so let's start by putting a 30, 60, 90 triangle on our unit circle. Okay, so the reason for that, okay, is we want to find the coordinates of a point on the circle, right? So what we're going to do is construct a right triangle here. Okay, and we're saying this is a 30, 60, 90 right triangle. Now, these are the ratios of our 30, 60, 90. Right? We talked about these a little bit, but we didn't work a ton with them. You've probably worked with them before in geometry, but these ratios, okay, will always stay the same. Right? If we think about the side opposite 30 as 1, the side opposite 60 as the square root of 3, and then the side opposite 90 as 2, I could multiply all three of those by any constant, right? So I could, multiply each of these by 5 and say that this is 10, 5, and 5 times the square root of 3, right? Those ratios hold. So in this case, in the case of the unit circle, what we're saying is the hypotenuse of any right triangle that we draw is 1, okay? If the radius of this circle is 1, the hypotenuse of any right triangle that we draw with a point on the unit circle will be 1. So what I want to do is think about taking these ratios and, I'm going to have to divide by 2 if I want the hypotenuse to be 1. Okay, so if I divide each of these by 2, we end up with this. Okay, we end up with a hypotenuse of 1. Then this side opposite 30 is 1/2. This side opposite the square, or opposite 60, is the square root of 3 over 2. So the coordinates of this point, okay, if this length of the right triangle is the square root of 3 over 2, the x coordinate of this point is the square root of 3 over 2. Then for the y coordinate, right, if this y distance of this right triangle is 1/2, the y coordinate of that point is 1/2. Now, the reason that this is significant is because if I think about trig functions of this right triangle, if I think about like sine and cosine of 30 degrees, all right, let's start with cosine. Okay, so cosine of 30 degrees we know is the adjacent side over the hypotenuse. So that would be the square root of 3 over 2 over 1. So it would just be the square root of 3 over 2. That is that actual coordinate point on the unit circle. Okay, that's why this is significant, because the actual coordinate point here just tells me the cosine of 30 degrees. We could do the same thing with sine. Right? I could say the sine of 30 degrees would be opposite over hypotenuse, which would just be 1/2 over 1. Again, that tells me that this value is the sine of 1/2. Or I'm sorry, the sine of 30 is equal to 1/2. Right? And that's true no matter how big this triangle gets, right? As long as we have a 30, 60, 90, the ratio of the opposite side to the hypotenuse will always be 1/2. All right, even if we just go back to this example, where we had this side was 1 and this side was 2. Opposite over hypotenuse is 1 over 2. If I were to multiply these by 17, right, I'd have 17 and 34. So 17 over 34 would reduce to 1/2. That ratio, if we have a 30-degree angle in a right triangle, the ratio of the opposite side to the hypotenuse is always 1/2. And if we start building our unit circle, the actual coordinate points here on the circle will tell me the values of these trig functions. Okay, that's why this is significant. So let's look at our 45, 45, 90 right triangle then. Okay, so these are the side lengths that we generally memorize when we're talking about a 45, 45, 90. Right? The two legs have the same length, and then the hypotenuse is just one of the legs times the square root of 2. But again, we want to think about the hypotenuse being 1. Right? So if I want this to be 1, well, to make this 1, I would have to divide by the square root of 2. So I'm going to divide everything here by the square root of 2. Okay, that means this would be 1, right? Square root of 2 over square root of 2 is 1. Then 1 over the square root of 2, we would want to rationalize and multiply top and bottom by the square root of 2. So we would say that these sides are the square root of 2 over 2. Okay, then those are both my x and y coordinates. Okay, the actual coordinate point here would be square root of 2 over 2, square root of 2 over 2. And again, the reason that that's significant is because we can now say the sine of 45, opposite over hypotenuse, would just be square root of 2 over 2, and actually the same with cosine. The cosine of 45 would be square root of 2 over 1. Okay? Then the final one that we're going to look at is a 30, 60, 90, but with the 60-degree angle down here. Okay, and we already looked at creating those ratios where this has a length of 1, the hypotenuse has a length of 1, and then my x coordinate will be 1/2, and my y coordinate will be the square root of 3 over 2. So the actual coordinates of this point are 1/2 square root of 3 over 2. And yet again, the reason that that's significant is because we can just say the cosine of 60 is 1/2, and the sine of 60 is square root of 3 over 2. Okay, so as we are starting to memorize these values and construct these, right, we also need to make sure we're understanding what they mean. Okay, and we'll talk about that again here at the end. But now what we want to do is take each of those and flip them into the other three quadrants. So if we start with our 30-degree angle, what we're actually going to do is look at all the other reference angles of 30 degrees. We talked about what a reference angle was in the last video, right? So a reference angle just means the measure from the x-axis, right? So here we're saying from here to here is 30 degrees. From the x-axis to here is 30 degrees, right? From the x-axis to here is 30 degrees. That's what a reference angle means. So all we're doing then, okay, first to get the actual measure here, okay, we're saying, well, if we're going from here to here, that would be 180 minus 30, so that would be 150 degrees. Or if we think about that in terms of radians, this would be pi. So pi minus pi over 6 would get me an angle of 5 pi over 6. Okay, so in terms of the coordinates then, well, if all I'm doing is taking this and reflecting it over the y-axis, the y coordinate will stay the same, and the x coordinate will just become negative. So here, this is the point square root of 3 over 2, 1/2. This would then be the point negative square root of 3 over 2, 1/2. Okay, all I'm doing when I'm reflecting across the y-axis is making the x coordinate negative. Similar idea down here then, okay? If I take a reference angle of 30, I would actually be adding 30 to 180, so this would be 210. Then in terms of radians, I would be adding pi over 6 to pi, so that would be 7 pi over 6. In terms of the coordinate point then, that would be negative square root of 3 over 2, negative 1/2. If I'm in the third quadrant, both the x and the y are negative. Okay, then finally, over here, if this reference angle is 30, that means that that would be 360 minus 30 to get 360 minus 30 to get 330, or 2 pi minus pi over 6 would be 11 pi over 6. Then if I'm in the fourth quadrant, we know that the x coordinate would be positive and the y coordinate would be negative. Okay, so we can do something pretty similar to this for our 45 and 60-degree angles. Okay, so for my 45s, right, here we said that this was a measure of 45 degrees. In terms of radians, that would be pi over 4. And our coordinate point was square root of 2 over 2, square root of 2 over 2. So again, if I just think about reflecting that across the y-axis, the coordinate point would just be negative square root of 2 over 2, square root of 2 over 2. And the angle measure, okay, would be, I can again think about this as I'm subtracting 45 from 180 if we're thinking in terms of reference angles. So 180 minus 45 would be 135, or pi minus pi over 4 would be 3 pi over 4. And then similar to get these points down here. Right? If I'm in the third quadrant, both the x and the y would be negative. If I'm in the fourth quadrant, the x would be positive, y would be negative. Okay. Similar for our 60-degree reference angles. Okay. So we said that that point on the unit circle here was 1/2 square root of 3 over 2. If I reflect that across the y-axis, again, same numbers, I would just have a negative x value now. So negative 1/2 square root of 3 over 2. In the third quadrant, both of those are negative. And then in the fourth quadrant, x is positive, y is negative. Okay. So I know I kind of went quickly through those last two. Okay, but let's put these all together here, and let me kind of talk about some strategies for memorizing these values. Right. The whole point of this is so that we can quickly have sine and cosine and even tangent of a lot of these angles just memorized, right? That's the whole point of memorizing the unit circle, right? And we are going to memorize this whole thing here. Okay, so I actually have a little clearer picture here of all of these values, right? So the angle measures, right? If we want to first just think about memorizing what angle measures we're talking about, we're talking about every multiple of 30 degrees, right? So first, if we just ignore the 45s, to get all the degree measures, what we're doing is we're just starting at 0 and going 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Okay. So, you know, make sure that you're filling in the unit circle on the bottom of your paper with all of these values, right? So first, we're just memorizing the angles. So if we do all the multiples of 30, then we do also have to do all the multiples of 45. Notice we skipped those when we went around the first time, right? So then we would do 0, 45, 90, 135, 180, 225, 270, 315, 360. So on both of those rotations, I did have to count these quadrantal angles both times, right? In our multiples of 30, we counted those, and in our multiples of 45, we counted those as well. Okay, so those are all of the angles that we're going to memorize as we're going around. Then, to get those in radians, okay, to get those in radians, we could sit and convert each one, right? We know our conversion factor to go from degrees to radians is just multiplying by pi over 180, but it's going to be quicker if we just memorize, okay? We can use that same trick. We can say that we're going to go around in multiples of 30, and then we can say that we're going to go around in multiples of 45. We can do the same thing for radians. For every 30 degrees for a radian, that is pi over 6. All right, so if I'm starting at 0, 1 pi over 6, 2 pi over 6, right? So I'm actually going to write that down here. So 2 pi over 6, then 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Okay, so the 30s, I'm just adding 1 pi over 6 every time. So then the ones that I wrote down in blue here, we would just need to reduce those, right? 2 pi over 6 would reduce to 1 pi over 3. 3 pi over 6 would reduce to pi over 2, right? And so on. So for our 30 degrees, okay, if I'm adding 30 degrees every time, I'm just adding pi over 6. We can do something very similar for our multiples of 45. That would just be adding pi over 4 every time, right? So here, this would be 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay, so we do need to memorize those quickly. Okay, ultimately, our goal is going to be to be able to just write all of those down in a matter of a couple of minutes. Okay, we want to have those angles memorized. Then we also need to memorize these points on the unit circle, these values. Okay, so one tip to memorize these values. Okay, let me. Okay, this has nothing to do with math. This is just a memorization trick. Okay, to memorize these values. I know that every single one of these is going to be over 2. Then all I do is I start here in the top left and go 1, 2, 3, 1, 2, 3. Okay? 1, 2, 3 down the left, 1, 2, 3 up the right, and then I take the square root of everything in the numerator. Okay? That's just a quick little memorization thing to help you remember these values here. Okay? Hopefully we don't need a trick to remember these points, right? The 1, 0, the 0, 1, the -1, 0, and the 0, -1. Then, once I have these values, all I'm doing is reflecting across the axes. Okay, so once I have these values memorized, all I'm going to do to flip these across the x-axis is make the x coordinate negative, right? So this point here, if I'm reflecting across the x-axis at pi over 3, I'll go to 2 pi over 3. So that point, if this is 1/2 square root of 3 over 2, this one will be -1/2 square root of 3 over 2. Okay, and so on. All I'm doing is making the x coordinate negative. Then I'm just going to take these values and flip them across the x-axis. When I do that, the both coordinates will be negative. Right? So I'm going to take this one, reflect it across the x-axis, and I will end up right here. So negative square root of 3 over 2, 1/2 would go to negative square root of 3 over 2, -1/2. And take this one, reflect it down, and take this one and reflect it down. Then do the same thing for the final quadrant. Okay? Take each of these points and reflect them over here. So this point would come over here, and I would make the x coordinate positive, but the y coordinate negative. Okay? So we do want to memorize these. All right. Now, I gave you a few tricks for memorizing, but the ultimate goal is to understand the point of this, to see why we're doing this. What's the point? Well, the point of this is to, once we have this memorized, we'll just really quickly be able to know things like the sine of pi over 2, right? Well, the sine of pi over 2 is the y coordinate at pi over 2. So at pi over 2, the y coordinate is 1. Right off the bat, I know the sine of pi over 2 is equal to 1. And we talked about that little memorization thing in the last video, right? To remember which one's which of these is the cosine and which is the sine. It's CS, Canton South. Okay, the x value is cosine, the y value is sine. Okay, so if I then want the cosine of pi over 2, all I'm doing is looking at that coordinate point and looking at the x value. So the cosine of pi over 2 is 0. Okay, the x coordinate at pi over 2 is 0. If I want, say, the sine of 135 degrees, oops. Well, I'm looking at the y coordinate at 135, so that would be square root of 2 over 2. And you will sometimes see our angles given in radians. Sometimes they'll be given in degrees. Okay, that's why we memorize both the degree measure and the radian measure for these angles. Right, we can interchange degrees and radians. Right, so the sine of 135 is the square root of 2 over 2. We could say that means the same thing as the sine of 3 pi over 4, right? Because 135 degrees and 3 pi over 4 are the same angle, just in different units, right? One's in degrees, one's in radians. Okay, so on the back of your paper, there are a few examples that we want to run through. Okay, just making sure we understand how to use the unit circle. Okay, so the first is actually the sine of 135, right? And we just said that that was the square root of 2 over 2, right? Because the y value of that coordinate point on the unit circle is the square root of 2 over 2. Okay, so I'm just looking at the unit circle, okay, to find that actual value. Okay, I mean, we could construct a right triangle here, say that this reference angle would be 45 degrees. If find the opposite and the hypotenuse, but we would ultimately find that that ratio is the square root of 2 over 2. The next one asks for the cosine of 240. So I want to go to my 240-degree angle and find the x coordinate. Okay? The x coordinate here is negative 1/2. So the cosine of 240 is just negative 1/2. The next one asks for the tangent of 315. Okay, so we haven't actually talked about tangent yet. What we just know is that um, our coordinates give me the cosine and then the sine. Well, we also talked about tangent is equal to sine over cosine, right? So if I think about this, would actually be equal to the sine of 315 over the cosine of 315. Well, then I can just go to my unit circle and say, well, the sine of 315 is the y value, so that would be negative square root of 2 over 2, over the cosine of 315 is square root of 2 over 2. So negative square root of 2 over 2 over square root of 2 over 2 would actually end up just equaling negative 1, right? So the tangent of 315 degrees is negative 1. We can use our unit circle to find tangents as well. We just need to think about and remember that tangent is equal to sine over cosine. Okay? In our next one, it asks for the secant of pi over 3. Secant, we know, is just the reciprocal of cosine. Okay, so I could say that this is equal to 1 over cosine of pi over 3. Another way of thinking about that is just on our unit circle, finding the cosine of pi over 3 and flipping it. Okay, so the cosine we know is the x value. So at pi over 3, the x value is 1/2. If I take the reciprocal of 1/2, that is just 2. Okay, so we can use our unit circle to find secant, cosecant, and cotangent as well. We just need to remember those relationships that we've talked about. Okay, that cosine and secant are reciprocals, sine and cosecant are reciprocals, and tangent and cotangent are reciprocals. Okay. The next one asks for the cosecant of 7 pi over 6. So we just said that's the reciprocal of sine. So this would be the same as 1 over sine of 7 pi over 6. So if I go to 7 pi over 6, we know that sine is the y value. So the y value is negative 1/2. The reciprocal of that would be negative 2 over 1, right? Or just negative 2. Our next one asks for the cotangent of 5 pi over 3. So I know that cotangent is the same as 1 over tangent, or if we think about that in terms of cosine and sine, right, that would be the cosine of 5 pi over 3 over the sine of 5 pi over 3. Okay, we said if tangent is sine over cosine, then cotangent would be the reciprocal, cosine over sine. So if we go to the unit circle, find 5 pi over 3, and we say the cosine is the x value, so that would be 1/2 over the sine, negative square root of 3 over 2. So now, okay, to simplify this, if I'm dividing fractions, that's the same as multiplying by the reciprocal. So this would be negative 2 over the square root of 3. My 2's would cancel, and I would end up with negative 1 over the square root of 3. We do need to rationalize if we have a radical in the denominator. So multiply top and bottom by the square root of 3, and we would end up with negative square root of 3 over 3. Okay. Then our final few examples here are values that aren't on the unit circle, but okay, we can find a coterminal angle that is on the unit circle and use that. Okay, so we talked about finding coterminal angles a few lectures ago. Okay, a coterminal angle is just an angle that begins and ends in the same spot. So we want to find a coterminal angle with 480. Okay. To do that, okay, we said all we're going to do is subtract 360 until we get to a value in between 0 and 360. Okay. So if I just subtract 360 from this, I would be at 120. So the sine of 480 is actually going to be the same as the sine of 120. Then I can look at my unit circle and say, well, the sine of 120 is just the y value at 120. That's the square root of 3 over 2. So the sine of 480 degrees is square root of 3 over 2. Okay, the next one is actually a negative angle. Again, that's not in between 0 and 2 pi, but we said, well, one way of finding a coterminal angle would just be to add 360 or to add 2 pi, right, if I have a negative angle. So adding 2 pi to this, negative 1/2 plus 2 would be 3/2. So I could say this is the same as cosine of 3 pi over 2. Well, 3 pi over 2 is right here. Cosine is the x value, so that is just 0. Okay, we actually should also be able to visualize what an angle of negative pi over 2 looks like. Remember, a negative angle just means I'm going to go backwards or clockwise. So if I'm starting here and I go negative pi over 2, hopefully we can see that we would just end up here, right? And the cosine, the x value, would be 0. All right. My last one is tangent of 21 pi over 4. So here, okay, I've got a very large angle. To find the coterminal angle, we want to start subtracting 2 pi until we get to a value in between 0 and 2 pi. So I'll write this out here. So 21 pi over 4, right? If I want to subtract 2 pi, well, 2 pi would be the same as 8 pi over 4. So I have my common denominators. So that would be 13 pi over 4. That is still not in between 0 and 2 pi, so I actually have to subtract 2 pi again. So 13 pi over 4 minus 2 pi again, right? 2 pi and 8 pi over 4 would be the same. So 13 minus 8 is 5. So we end up with 5 pi over 4. So this tangent of 21 pi over 4 is just going to be equal to tangent of 5 pi over 4. Well, to find tangent, we have to find the sine and the cosine. So I need the sine of 5 pi over 4 over the cosine of 5 pi over 4. The sine at 5 pi over 4 is negative square root of 2 over 2. And the cosine is also negative square root of 2 over 2. Same thing over same thing, that actually just reduces to 1. So my final answer here, the tangent of 21 pi over 4 is just 1. Okay? So we do need to memorize all of these values. We will have a quiz soon, okay, where you're just going to get a piece of paper that looks very, very similar to your notes there, and you just have to fill in every single value. Okay, all the angle measures in degrees, all the angle measures in radians, and then all of those coordinate points. And then also on that quiz, I will ask you a few questions like what we just did, where you have to use the unit circle to find certain trig values. Okay, so that is it for this video. The final question is going to pop up asking you what questions you have.